Before there was sound, before there was movement, before there was even the faintest trembling of a possibility, there was something else. Not emptiness, not nothingness, but a kind of poised silence. A silence so total it was neither absence nor presence. It was the waiting breath before breath itself existed. In that stillness, time did not yet flow. There was no before or after, no motion to mark a beginning. There was only potential, stretched infinitely thin, like the pause before the first note of an eternal song. This was the silence before time. The moment when existence was not yet sure whether it wanted to exist. It was a cosmic hesitation, a hesitation that contained everything that would ever be. The stars, the oceans, the atoms of our bodies, the thoughts that would one day name the silence itself. All of it lay suspended in an equilibrium so fragile that the slightest whisper could tip it toward being or nothingness. And perhaps it did. Perhaps the universe began not with an explosion, but with a decision made in that stillness. A choice between the ache of becoming and the peace of remaining unmade. If you could drift backward through all the ages, past the light of galaxies and the ashes of collapsing suns, you might find yourself there, in that unmoving sea. You would not see anything. You would not even see darkness, for darkness requires contrast, and there was no contrast yet. There was no distance between things, no separation to define what was or wasn't. Only a vastness so unified that even the concept of vastness loses meaning. This is where the story begins, not with sound or flame, but with an almost unbearable quiet. In that quiet, something stirs. Not a sound, but the faintest suggestion of direction, of differentiation. It is as if the silence itself begins to listen to itself, and in that act of self-attention, the seed of time is born. Time, that river we float upon without question, once did not flow. It was a dormant potential, a still pond before the first ripple. And when it finally began to move, it brought with it the entire architecture of existence. Energy, matter, space, and story. Yet even now, deep beneath all that motion, the original stillness remains, the first foundation beneath every pulse of creation. Some say the universe emerged from a singularity, a point of infinite density and zero volume. But what does that mean? To say something came from nothing is to use language meant for space and time, in a realm that knew neither. What if, instead, the singularity was not a thing, but an idea? A moment of perfect compression, when all possibilities coexisted without conflict. Within it, there were no beginnings or endings, no sequence, only potential stacked upon potential. Every atom that would one day make a mountain or a cell or a thought waited there, undefined, timeless, patient. Imagine that state. A silence filled with everything that would ever be, dreaming of itself. Perhaps this dream was the first true movement. A flicker of curiosity within the void, asking, "What am I?" That question might have been enough to fracture the symmetry. To turn silence into echo, stillness into expansion, nothing into something. The first wave of becoming rippled outward, and from that, the clock of existence began to tick. Time unfolded like a breath drawn slowly in, and the universe began to exhale into being. Even now, that ancient quiet hums underneath everything we know. It hums beneath the static of the cosmos, beneath the movements of our thoughts. We call it vacuum energy, zero-point field, quantum fluctuation, names for something we can measure but not understand. Scientists describe it as the restless energy that fills even the emptiest space. But perhaps it is more than that. Perhaps it is the echo of the silence that came before, still murmuring softly beneath the rhythm of time. A reminder that before all beginnings, there was stillness. And within that stillness, a fullness too vast to vanish. Every beginning carries a shadow of its before. Every sound emerges from silence and returns to it. The universe, too, will one day slow, cool, and fade into that same eternal hush. And maybe that is not an end at all, but a return. The silence before time may not just be behind us, it may be the destination toward which everything gently falls. The story of existence might be a single breath, inhaled in the birth of stars, exhaled in the death of light, and finally held again in timeless peace. Close your eyes for a moment. Feel the quiet around you. Beneath the hum of machines, beneath the rhythm of your heart, beneath even your thoughts, there is a deeper silence, a vastness that does not move. That stillness is not separate from the one that once filled the cosmos. It is the same pause, the same unbroken calm. We are the continuation of that first silence, shaped into sound, life, and thought. And though time flows around us, though the story rushes ever forward, somewhere deep within, that ancient hush remains untouched, holding the memory of the moment when nothing and everything were the same. In that realization lies a strange kind of peace. To know that before all beginnings, there was calm. That the universe itself began from quiet reflection. That even if everything ends, silence will cradle what remains. The silence before time was not emptiness. It was presence. It was the first breath waiting to be drawn, the first note waiting to be sung. It was, and in a way, it still is, the quiet pulse beneath existence, reminding us that every end is only a return to the stillness that began it all. When the universe finally awoke, it did not roar into being as legend so often imagines. There was no deafening explosion, no sudden blaze of color. It was more like a whisper, a faint stirring of warmth across an infinite stillness. Out of the silence before time, the first tremor of light unfolded. It was fragile, delicate, almost uncertain of its own reality. For a moment that felt outside of all measure, the universe balanced between existing and not. And then, in the smallest shimmer of expansion, it began. In those first moments, less than a heartbeat in cosmic measure, the universe was a soft breath of plasma and possibility. Everything we know today, the atoms of our bodies, the dust of stars, the thought you are having now, was already there, compressed within a space smaller than imagination can hold. Time began to move, and with it came the first murmur of energy, of difference, of transformation. But this was no grand spectacle. It was a slow unfurling, a tender birth in the dim glow of creation. The universe was not yet visible. It was still a whisper in darkness, still a child wrapped in warmth, learning how to exist. Physicists call these early moments the Planck era, when laws of physics themselves were forming, when gravity and light, matter and motion all emerged from unity. It was an age when the universe could not yet decide what it wanted to be. The simplest rules of existence, the ones we rely on without thinking, were still taking shape. Space itself was stretching, pulling gently outward like the skin of a bubble. Light scattered but could not travel far. The universe was too thick, too bright, too hot to let illumination move freely. It was glowing softly, a pulse of golden haze, a heartbeat of the cosmos before eyes existed to see it. Imagine the universe then, not as a spectacle of sound and fury, but as warmth, as potential, as the tender hum beneath all future songs. It was a whispering expansion, like dawn before dawn. It had no stars yet, no galaxies, no direction. Every atom was a traveler without a map, carried in a stream of light and heat. And still, something was taking shape, a pattern hidden in the blur. The smallest differences in density, the tiniest asymmetries, would one day become everything: stars, planets, oceans, thought. Every fluctuation, no matter how faint, was a word in the language of becoming. The universe was whispering its first story, syllable by syllable, particle by particle. There is a haunting beauty in how close existence came to vanishing. The laws that formed could easily have balanced differently, and the universe might have remained forever still, a momentary shimmer erased before memory could take hold. A fraction more mass, and everything would have collapsed inward. A fraction less, and matter would never have gathered. Yet somehow the balance held. From that whisper, a harmony emerged so precise it feels intentional, though it may only be chance. The cosmos did not shout, it breathed. It did not demand to exist, it allowed itself to unfold. Billions of years later, that whisper still echoes. The faint afterglow of those first moments, the cosmic microwave background, still fills every corner of space. It is the ancient light that never stopped traveling, a soft remnant of the universe's first whispering breath. When astronomers tune their instruments, they can still hear it, a background hiss, older than any star, older than the first atom. It is the universe's oldest memory, the sound of creation humming gently beneath existence. Every second of every day, that whisper touches you. It passes through your body unnoticed, bathing everything in the soft residue of the first light. To imagine the beginning as a whisper is to reimagine what power means. We are taught to see creation as violence, as force, as eruption. But perhaps creation was an act of patience, a long, quiet exhalation into possibility. The universe, in its infancy, was fragile enough to disappear, yet it endured. It was vulnerable, tender, and uncertain. And maybe that is the secret truth of beginnings. They rarely arrive as thunder. They come softly, almost imperceptibly, until one day you realize that everything has changed. In those early minutes, as the universe expanded and cooled, matter began to take its first uncertain forms. Protons and neutrons bound together, forming the simplest atoms: hydrogen, helium, a trace of lithium. There were no heavy elements yet, no oxygen for breath, no carbon for life. Those would come much later, forged in the hearts of stars that did not yet exist. But even in this whispering dawn, the seeds of every future world were already drifting through the young cosmos, waiting for the right moment to awaken. The universe was not yet luminous, but it carried within it the promise of light. Time itself was stretching. The expansion that began as a flicker continued endlessly outward. Every second added new space, new possibilities, new silence between things. And within that silence, structure began to emerge. Invisible threads of gravity pulled on the newborn matter, weaving the faint outlines of galaxies that would take billions of years to form. The whisper of the beginning had become a song too low for us to hear, yet its rhythm shaped everything that followed. Even now, when you gaze at the night sky, what you see are echoes of that ancient murmur. Every star, every spark of light, carries within it the story of that soft awakening. The photons that reach your eyes began their journey in that whispering dawn, when the universe was only a few 100,000 years old. What you are seeing is not merely starlight. It is the oldest memory of light remembering itself. And perhaps this is what the universe has always been. A vast memory of a single, quiet decision to exist. A moment when nothingness trembled, hesitated, and softly became something. That whisper has never stopped. It moves through every heartbeat, every wave, every breath. It is the tone beneath the hum of galaxies, the calm beneath the chaos of time. The whisper that began everything is still here, still speaking, in the silence between seconds. After the whisper of creation faded, the universe entered a strange and haunting silence, a darkness so complete that it might have seemed like the story had ended before it truly began. The light that had once filled everything dimmed as the cosmos expanded and cooled. The early radiance stretched into invisibility, leaving behind a vast, starless sea. For hundreds of millions of years, there were no suns, no galaxies, no color. Only hydrogen, helium, and the faint afterglow of the first light drifting endlessly outward. This was an era we call the Cosmic Dark Ages, an age forgotten not because it was brief, but because it left no trace that light could remember. It is a paradox, this dark age. The universe was full, yet empty. Alive with potential, yet without form. It had everything required for beauty, but none of the structure through which beauty could be seen. Space was heavy with invisible matter, rippling gently with the echoes of its own birth. Tiny fluctuations, too faint to imagine, were gathering mass, slowly, invisibly, patiently. It was a silence that wasn't lifeless. It was gestation. The universe was dreaming, shaping itself in the dark. Every particle that now burns in a star or breathes in a living thing was already drifting then, waiting for gravity's hand to bring it together. In that timeless hush, gravity began to weave. Small clouds of hydrogen gathered and merged, guided by threads of unseen dark matter. Where they thickened, heat began to rise. And deep inside those growing clouds, something extraordinary was preparing to happen. The first stars were forming, not in isolation, but in clusters, in vast cosmic nurseries that glimmered faintly through the black. Yet even before those first stars ignited, The universe was already humming with their anticipation. The silence was trembling with possibility. When the first stars finally lit, the darkness ended. But the age before them, the age of invisible waiting, was longer than all of human history by billions of years. It is an era beyond memory, beyond sight. No telescope can show us what it looked like, for there was no light to capture. Yet we can feel its presence in the patterns of the cosmos today, like a ghost beneath the living world. Every galaxy, every sun, every atom of carbon in your body owes its shape to that long, invisible waiting. The Dark Ages were not absence. They were preparation. There is a strange kinship between that ancient silence and the spaces within our own lives. The pauses between thoughts, the years of seeming stillness when nothing appears to grow. Yet, in that stillness, formation occurs. Invisible change. Deep work. The universe, too, needed time to gather itself, to cool, to let gravity sculpt the outlines of what would come. It teaches that even creation requires patience, that the most luminous moments are born from stretches of silence so vast they are almost unbearable. If one could drift through that dark universe, there would be no stars to navigate by, no glimmer of orientation. Only the faint afterglow of the Big Bang stretched into microwaves, whispering quietly across endless distances. You would be surrounded by hydrogen fog, cold and indifferent, and yet it would be the womb of everything to come. This was the forgotten age of light. Forgotten, because light itself was sleeping. And still, beneath the silence, the cosmos was busy dreaming. When the first stars finally flared, they did more than illuminate the void, they changed its nature. Their energy reionized the universe, clearing the fog, making space transparent for the first time. But in doing so, they ended that mysterious, private time, the long night that remembered only itself. It was a cosmic threshold, the moment light returned and memory began. Everything before it now lies hidden behind a veil, unreachable, irretrievable. We know it only through echoes and mathematics, through the delicate ripples left in the afterglow of creation. There is something deeply moving about this idea, that most of cosmic history is invisible to us. The Dark Ages hold stories we will never read, structures that collapsed before they shone, attempts at light that failed before they could be seen. The universe, like consciousness, forgets. It leaves behind ghosts of possibilities that never came to pass. We live in a cosmos built not only from what survived, but from what almost did. Every moment of being rests atop countless vanished beginnings. In the human heart, too, there are dark ages. Times when we feel unseen, unformed, drifting in silence. Yet those are the ages when gravity is gathering within us, pulling fragments of who we are toward one another. They are not voids, they are gestations. Like the universe in its earliest slumber, we carry invisible futures within us. We forget that the dark is not the opposite of light, it is its birthplace. And so, the forgotten ages of light were not wasted. They were the pause before illumination, the long inhale before the first exhale of starlight. They remind us that even the most desolate stretches of time hold the seeds of radiance. That what seems empty is often only waiting for its moment to shine. When the first stars finally pierced that vast silence, they were not sudden miracles. They were the slow flowering of everything that had ever been promised in the dark. In this way, the universe has always known patience. It has always known how to hold silence until the right moment arrives. We, too, are made of that same patience. Every cell in us carries the memory of those ages of waiting, the quiet confidence of a cosmos that once drifted alone and unlit, certain that one day, somewhere, light would bloom again. The forgotten ages of light were not forgotten by the universe. They live in every photon that travels through space today, in every flame, every sunrise, every heartbeat that glows in the dark. They are the unseen chapters of existence, the story of a universe that learned to shine only after it learned to be still. Before the earth we know began to breathe, before continents formed and oceans gathered, there was a restless dance around the newborn sun. Space was filled with fragments, shattered stones, molten shards, and rivers of dust spiraling through light. The solar system was not yet a harmony, it was a storm, Planets were not born whole, but from endless collisions and losses. Every world that now glides in its stable orbit was once a wound, a scar of impact, a survivor of cosmic chaos. And within that storm, countless Earths almost were. Worlds that tried to form, that nearly found balance, only to be broken apart and forgotten. These are the ghosts of creation, the worlds that ended before they began. Imagine that early time, the sun blazing young and fierce, its light heavy with radiation. Around it, a great disk of dust and gas turned slowly, shimmering with heat. Within that spinning chaos, small grains collided and stuck together, growing into pebbles, then stones, then mountain-sized bodies called planetesimals. Each of these was a promise, a potential world, gathering mass, shaping gravity, dreaming of stability. But most of them would never see the calm of a sunrise. They collided, shattered, and began again. It was an age of endless beginnings, each one fragile, each one short-lived. In that turmoil, one of those many forming worlds began to gather more than the rest. Piece by piece, it pulled its neighbors into itself. Its collisions grew more violent, but through destruction it became more whole. It was this world, the early Earth, that endured. But even its endurance came at a cost. In one of the most profound impacts in cosmic history, another forming planet, roughly the size of Mars, struck the young Earth. The collision was apocalyptic. Oceans of rock vaporized, the surface melted into magma, and fragments of both bodies were flung into orbit. From that cataclysm, the moon was born, a child of impact, a memory of loss turned into light. Every beginning on Earth's path came through ruin. The world that now carries life was forged in destruction after destruction. It was never a peaceful birth. It was a succession of deaths that refined what could survive. Each failed attempt, a shattered planet, a melted surface, a fragment of orbit, was a necessary note in the symphony of endurance. The Earth dream, the world that almost wasn't, is not just the one that survived. It is all the ones that didn't, echoing quietly in the dust beneath our feet. Scientists believe there were many proto-Earths, competing to exist in the early solar system. Some were swallowed by the sun, others thrown into the outer dark, their cores frozen in silence. Each of them carried unique chemistry, unique possibility. Somewhere in their vanished crusts might have been the first recipes for oceans or minerals we now find here. When they were destroyed, their materials were not lost. They became us. Every atom on Earth carries the memory of worlds that failed to be born. In this way, our planet is not singular. It is a mosaic of endings, the amalgam of dreams undone. It is a haunting thought that even success in the cosmos is made of loss. That creation, on its grandest scale, is always entangled with destruction. Yet there is a quiet beauty in it too. The Earth dream teaches us that existence is not a straight path from nothing to being. It is an ocean of attempts, of collapses and continuations. It is what happens when persistence meets chance. Even the atoms in our bodies, iron, carbon, calcium, were born from stars that exploded long before the solar system existed. We are, in every way, made from worlds that ended before they began. When the surface of Earth finally cooled, the air was thick with steam and fire. The crust hardened, cracked, and reshaped itself over and over. Continents did not exist yet, only islands of rock drifting on molten seas. Comets rained down, carrying water and organic molecules. Lightning flashed through clouds of methane and hydrogen, perhaps striking pools of primordial ocean, stirring the chemistry of life. The planet was still a battlefield of creation and collapse, but within it, something had changed. It was no longer pure chaos. It was potential, slowly finding rhythm. It's easy to imagine this early Earth as violent, but beneath that violence was an astonishing tenderness. The forces of gravity and heat, of destruction and rebirth, were not enemies. They were sculptors, carving order from disorder. Each collision spread energy that allowed matter to reorganize into something new. Each loss gave rise to the conditions for stability. The magma seas cooled, the skies began to clear, and water gathered in basins deep enough to hold reflection. And in those reflections, perhaps the universe saw itself and paused. When we think of beginnings, we often imagine them as clean moments, a first step, a first light, a first word. But nature's beginnings are never singular. They are layered, recursive, born from ruins. Earth's creation was a long chain of almosts, almost worlds, almost oceans, almost calm. Each failure made the next possibility more refined, more resilient. The story of Earth is not about one miraculous birth. It is about countless imperfect attempts, blending and breaking, until one was stable enough to hold time. In that sense, the Earth dream still continues. The planet beneath us is not finished. It moves, shifts, breathes. Mountains rise and erode, continents drift apart, oceans deepen and dry. The same forces that shattered worlds still move quietly below our feet. The Earth is still dreaming itself into being, as it has for 4.5 billion years. It is not a static world. It is the ongoing consequence of every beginning that came before. And within that motion, we exist, small, brief, and luminous. Our bodies are echoes of the early collisions, our cells filled with the remnants of cosmic dust. Every heartbeat is a continuation of the rhythm that began when molten worlds collided in darkness. The Earth dream is not only the planet's story, it is ours. We, too, are formed through impact and healing, through loss and renewal. Like the planet, we are mosaics of unfinished beginnings. Perhaps, in the grand view of the cosmos, every world is an Earth dream, every life, every age. The universe is not a sequence of perfect creations, but a constellation of almosts. Some flicker briefly, others endure long enough to awaken awareness. And though many worlds end before they begin, none of them are wasted. Each leaves behind a trace, a particle, a memory that contributes to what will come next. The Earth we know is simply the one that remembered how to keep going. The Earth, still young and molten, was a planet of fire and glass. Its surface boiled with heat, oceans of magma shimmering under the glow of a newborn Sunday. Volcanoes erupted endlessly, spewing rivers of lava that carved the planet into new forms, only to have them remade again by the next wave of fire. The air was thick with ash and smoke, a haze that blurred the line between sky and land. Lightning arced through clouds heavy with primordial gases, striking the molten crust and igniting chemical reactions that would lay the foundation for life. This was an age both violent and creative, where destruction and formation existed as inseparable partners in the slow choreography of becoming. Every eruption, every collision, every tremor carried with it the possibility of transformation. The early Earth was not simply a ball of rock. It was a crucible, forging matter and memory from the raw forces of the universe. Minerals were born in the heat, their crystalline forms forming in the slow cooling of lava flows. Oceans of liquid rock shifted continents into place, shaping the patterns that would one day guide water and life. The surface was unstable, yet in its instability lay the potential for endurance. Each fiery act was a lesson in resilience, teaching the planet how to persist in the face of chaos. Beneath the fiery surface, energy moved in currents too vast and slow for human comprehension. Magma pulsed like a heartbeat, carrying heat from the core to the crust. In that pulse, the elements necessary for life, the carbon, nitrogen, phosphorus, and iron, were redistributed, spread across the planet in patterns that seemed random, yet would later form the bedrock of oceans, rocks, and eventually living tissue. The planet itself was a laboratory, experimenting with combinations, testing what could survive and what would dissolve. In this way, the age of fire and glass was not simply a time of destruction. It was a period of preparation, an unseen teacher shaping the conditions for the ages to come. The sky, too, was alive. Clouds of volcanic ash created the first weather systems, carrying moisture in the form of steam and gases. Lightning struck again and again, energizing the primordial atmosphere. The chemistry of the air, combined with the heat of the surface and the composition of the oceans, set the stage for molecules to assemble in ways that would later be essential for life. The planet was a crucible not just of rock, but of possibility, each eruption a spark, each thunderbolt a note in a silent symphony of creation. There was a rhythm in this chaos, subtle and slow, almost imperceptible. It is easy to imagine only the violence, only the heat and destruction, and yet beneath it all there was a kind of order emerging. The planet's rotation, its tilt, the slow drift of continents and oceans, the pulse of internal heat, all of these combined to create a pattern of transformation. The Earth was learning, shaping itself into a form capable of holding complexity. Even before life existed, the planet had memory, a record in its rocks, its minerals, and its shifting crust of the forces that had shaped it and the fires it had endured. Volcanoes were both destroyers and creators. Lava flows buried valleys and then raised them again. Ash settled in layers that would one day be studied by future generations as clues to the planet's infancy. Mountains were uplifted and then eroded, their jagged peaks softened by time. In every act of destruction, there was also an act of preservation, an imprint left for the future. The Earth was writing its own history, layer by layer, eruption by eruption, heatstroke by heatstroke. Even the oceans, though still forming, were shaped by this age. Steam from magma cooled in the atmosphere, condensing into the first rains that would collect in basins and craters. These pools became the earliest reservoirs of water, mixing with minerals leached from the rocks. In these pools, the first chemical reactions could take place, small experiments in the alchemy of life. The age of fire and glass, though often imagined as inhospitable, was already setting the stage for the delicate balance that would later sustain oceans, atmosphere, and life itself. There is a strange poetry in thinking about this time. Every molten river, every volcanic eruption, every lightning strike was both an ending and a beginning. The planet was simultaneously destroying itself and building itself, showing us that creation is rarely gentle. To endure is to be remade again and again, to be forged in fire, tempered in chaos. The Earth was learning this lesson long before we existed to recognize it. In the rhythm of destruction and formation, it found a path toward stability, toward life, toward memory. Even now, beneath the surface, the echoes of this age remain. The heat of the Earth's core, the movements of tectonic plates, the presence of minerals formed in magma, all are reminders of this fiery youth. Volcanoes still erupt, mountains still rise, and oceans still move across continents. The age of fire and glass was not a single moment in the past. It is an ongoing rhythm, a pulse that continues beneath our feet, shaping the conditions of life and the possibilities of tomorrow. In contemplating this era, we see that chaos is not the opposite of order, but its foundation. The fires that shaped the Earth were not mere destruction, they were instruction. They taught the planet to endure, to evolve, to hold the complexity necessary for life. And in that, we glimpse a universal truth. Creation often comes wrapped in violence and uncertainty, yet it is precisely in those moments that the possibility of all that follows is born. The Earth, forged in fire and tempered in glass, carries in every rock, every mineral, every shifting layer of its crust the memory of its own becoming. It is a reminder that all growth, all transformation, carries within it the echo of what was broken, melted, and reformed. As the molten crust of Earth began to cool, water arrived, not all at once, not as oceans fully formed, but as countless tiny gifts from the cosmos. Comets, icy and silent, carried frozen molecules across the void, crashing into the young planet with quiet persistence. Asteroids, too, delivered minerals and traces of organic matter. Slowly, imperceptibly, pools of water began to collect in low basins, cradled by the cooling rock. Steam rose into the atmosphere, forming clouds heavy with moisture, and eventually, the first rains fell, tapping out rhythms that would echo through time. This was the Earth's first breath, the inhalation of oceans that would hold its earliest memories. The arrival of water transformed the planet. Where once magma had flowed unbroken, now streams of liquid carved channels and pools of rainwater gathered in depressions, reflecting the fiery sky above. The chemistry of the water, mingling with minerals leached from rock, set the stage for the formation of complex molecules. Life as we know it was not yet possible, but the ingredients were slowly assembling, stirred by lightning, heated pools, and the quiet patience of time. Water was not simply liquid. It was a medium of memory, a cradle for the processes that would one day give rise to consciousness itself. The first oceans were not calm. They boiled and churned under the heat of a young sun, their surfaces tinged with minerals leached from the Earth's crust. Yet in their turbulence, a subtle order began to emerge. Convection currents circulated nutrients and energy, mixing the components needed for the first chemical reactions that might be considered precursors to life. In this way, the oceans became more than reservoirs of water. They became active participants in the slow experimentation of creation. Every wave, every ripple, carried the potential for something new, for the first flickers of self-organization. Water also changed the shape of the planet. It eroded rock, deepened basins, and smoothed the edges of molten scars. The first rivers began to flow, carving channels that would guide future seas. The presence of water allowed the atmosphere to stabilize, forming a protective layer of vapor and gas that would, over eons, make the planet hospitable. In these ways, water became both sculptor and guardian, shaping the contours of the earth while shielding it from the worst of the sun's young fury. There is poetry in the arrival of water, a liquid born of distant stars, falling from the sky, pooling in silent basins, waiting for life to arrive. It is a reminder that our planet is not isolated, that every drop carries a story of journeys across light years of space. Even now, the oxygen in the water, the hydrogen in our cells, the calcium in our bones, all were shaped in that early cosmic ballet. The oceans, in their first breath, were a ledger of the universe's generosity, recording the interplay of chance and law, of destruction and creation. Beneath the surface, the chemistry of the oceans was already rehearsing the patterns of life. Organic molecules formed spontaneously, drawn together in warm pools and shallow tides. Amino acids, sugars, and nucleic acids, the building blocks of future organisms, drifted together, guided by the gentle stirrings of water and heat. Each reaction was fleeting, fragile, almost insignificant on its own, yet collectively they prepared the way for self-replicating systems. In this sense, water was more than a habitat. It was a teacher, instructing molecules on movement, interaction, and persistence. The rhythm of tides began to emerge, shaped by the gravitational influence of the moon, born from the cataclysm that had struck the young Earth. This subtle, predictable movement provided an oscillation, a gentle pulse within which early chemical experiments could persist. With each ebb and flow, molecules were separated and reunited, creating cycles that enhanced the complexity of reactions. Water was time-made liquid, carrying the slow heartbeat of planetary processes and the possibility of life within every drop. Even as the oceans stabilized, they remained vast and mysterious. Their depths concealed turbulent undercurrents and heated vents, places where energy and chemicals met in strange, fertile combinations. These hidden realms, dark and seemingly inhospitable, were likely the first laboratories of life. Here, in the deep pressure and the warmth of chemical reactions, the first forms of metabolism may have begun, long before organisms would appear to swim and float. The oceans, it seemed, held secrets that the surface world could only imagine, quietly carrying the story of everything that might one day breathe and grow. In contemplating these first waters, one can sense the subtle intelligence of the planet. Life had not yet arrived, but the stage was set. Water orchestrated complexity, maintained cycles, and provided stability amid chaos. It was both medium and message, a flowing record of the planet's fiery and violent youth, carrying minerals and molecules across its surface, creating gradients and boundaries where order might emerge. Every drop was a vessel, every current a teacher, every wave a pulse of possibility. And as we consider these oceans, we recognize that they are still the same waters that carried the first whispers of life. They are ancient, immense, patient. The tides that wash upon our shores echo the first rains and the first streams that gathered in primordial basins. The oceans are the planet's memory, holding in their depths the story of collisions, impacts, and distant comets. They are the first breath of Earth, the lungs of the world, carrying forward the legacy of beginnings, endings, and transformations yet to come. The first breath of the oceans reminds us that life, even in its simplest form, is inseparable from the rhythms of water. It is a medium in which time and chemistry dance together, a soft, flowing keeper of memory. Without these ancient pools, the story of the Earth would remain a story of fire and stone alone. But with them, the planet began to breathe in possibility, exhale potential, and cradle the future in its liquid heart. From this breath, all ages of life, all moments of consciousness, all histories, visible and invisible, would eventually arise. Beneath the surface of the young oceans, life stirred quietly, invisible and unassuming. There were no eyes to see it, no voices to mark its presence, no footprints to leave behind. The first organisms were microscopic, yet astonishingly complex in their simplicity. Single-celled creatures floated in the primordial waters, their membranes delicate shields against a world still wild with chemical turbulence. They absorbed nutrients, divided, and multiplied, carrying within them the earliest echoes of metabolism. Life existed, yet it had not yet begun to shape the world in ways we could perceive. It was patient, hidden, and profoundly experimental. These early life forms were chemists, engineers, and alchemists all at once. Within the water, they gathered energy from the simplest reactions, splitting molecules, capturing sunlight, or feeding on the chemical richness delivered by volcanic vents and drifting comets. Every action was a test, every division a rehearsal. Life was improvisational in those early oceans, forming patterns without guidance, following rules that had not yet been written. It was both fragile and persistent, tiny flickers of organization against the vast backdrop of a planet still dominated by fire, tides, and turbulence. For billions of years, life remained largely confined to the oceans. Land was hostile, air was poisonous, and sunlight was filtered through layers of clouds and haze. Within the depths, however, a quiet revolution was taking place. Cyanobacteria, the architects of oxygen, began to emerge. They captured sunlight in a process that transformed the chemistry of the oceans and eventually the atmosphere. This quiet work would, over immense spans of time, lay the groundwork for every future breath, every forest, and every creature that would walk upon land. In this way, even the smallest organism bore the weight of the future, unconsciously carrying the possibility of all that was to come. There is a paradox in this long aquatic age. For all its duration, it left almost no trace. Fossils were rare, chemical signatures faint, and yet the processes of life were profound. Microbial mats and stromatolites became the first archives of living activity, recording in layered patterns the slow dance of organisms that had no consciousness of themselves. Life, in these ages, was both ephemeral and eternal. It existed quietly, invisibly, yet in doing so, it shaped the very chemistry of the planet, nudging it ever closer to stability and complexity. This prolonged confinement beneath the waves also created resilience. Life learned to endure extremes, heat and cold, acidity and salinity, chemical storms and nutrient scarcity. Those organisms that survived did so not because they were strong in the way we imagine strength, but because they were adaptable, patient, and responsive to subtle patterns in their environment. Evolution in these oceans was a slow, almost meditative process, a series of small adjustments that over time allowed life to expand into increasingly complex forms. It was the universe's first lesson in persistence, that growth often occurs unseen, beneath the surface, in silence. The oceans of this time were not static. Currents swirled, tides ebbed and flowed, and chemical gradients shifted with the heat of the young planet. Life rode these currents, moving where energy and nutrients converged, drifting with the planetary rhythms. It is easy to imagine these early organisms as insignificant, yet they were conducting experiments with every chemical encounter, every cellular division. Within these tiny laboratories of water, life was learning the rules of survival, interaction, and adaptation. It was an age of experimentation, trial and error, successes and failures so small that they left no mark beyond the invisible chemistry of the seas. Life's confinement also imposed a quiet discipline. Without air to breathe, organisms were forced to optimize every reaction, every energy transfer. Without sunlight at depth, some turned to chemical energy from volcanic vents, creating the first symbioses and the earliest examples of cooperation. Even in these hidden depths, There was a rhythm, a pulse, a learning process that would one day resonate through every living thing. Life had not yet walked, flown, or thought. It had only persisted quietly within the embrace of water. There is a profound poetry in this age, for it was both fleeting and eternal. Life had begun, yet it had not yet claimed the land or sky. It existed as a whisper, a hidden hum beneath the surface, experimenting with existence itself. Every cell carried within it the memory of chemical beginnings and the potential for infinite futures. This is the essence of the ocean's first life, not spectacle or grandeur, but quiet, patient endurance. It is the memory of an age that almost went unnoticed, yet upon which all subsequent life would be built. The lessons of these unseen ages extend beyond biology. They remind us that much of creation occurs silently, patiently, and without recognition. That growth and innovation often take place beneath our notice, in places too small or too subtle to observe. And perhaps the most remarkable aspect of this early oceanic age is that it endured, persisted, and prepared the planet for the emergence of life that would eventually breathe air, build civilizations, and reflect upon the very origins of existence. Life that remained in the oceans was not passive. It was the first witness to Earth's unfolding story, the quiet precursor to everything that would come to walk, swim, and fly upon the planet's surface. Even now, as we look back across billions of years, it is humbling to consider the patience of these earliest forms of life. They existed in silence, without knowledge or purpose, yet laid the foundation for all future complexity. The ocean, vast and deep, cradled these pioneers, teaching persistence, adaptation, and the subtle power of endurance. It was an age that could have ended unnoticed, an entire world of living experiments that might have faded forever. And yet, through that quiet persistence, the stage was set for every form of life to come, a hidden chorus of beginnings singing softly beneath the waves. The oceans, vast and restless, held within their depths a quiet alchemy. For billions of years, life had remained small, almost invisible, drifting with the currents, experimenting with the simplest forms of energy and matter. Yet slowly, imperceptibly, these tiny organisms began to interact in ways that would transform the entire planet. They did not speak, they did not move with intention, and they did not perceive themselves as agents of change, but their collective presence altered chemistry, climate, and eventually the very air itself. It was a patient revolution, unfolding without fanfare, a slow awakening of the Earth's capacity to sustain complexity. Through the process of photosynthesis, cyanobacteria began to release oxygen into the oceans. At first, it was a quiet seepage, absorbed by iron and other elements, leaving almost no trace in the atmosphere. Yet, over millions of years, oxygen began to accumulate. The seas, once rich in dissolved gases and minerals, were slowly transformed into a new medium, capable of supporting forms of life never before imagined. This quiet shift, so gradual that it passed almost unnoticed, was the prelude to one of the most dramatic changes in the history of Earth, the Great Oxidation Event. Life itself was beginning to reshape the conditions of the planet, long before anything could consciously understand its power. The oceans were now laboratories of profound experimentation. Chemical gradients created pockets where life could explore increasingly complex interactions. Molecules were rearranged, bound, and dissolved, creating pathways for energy flow that would later define metabolism and respiration. Symbiosis, cooperation, and competition began to emerge in microcosm, invisible to all but the molecular scale. Each adaptation, each incremental change, carried with it the possibility of survival and expansion. Life, in its quiet persistence, was teaching the planet how to become a cradle for more intricate forms of being. In these turbulent, nutrient-rich seas, the first eukaryotic cells, the ancestors of all complex life, began to appear. They were larger, more organized, and more capable than the simpler prokaryotes that had dominated the oceans for eons. Within their membranes, compartments formed, separating chemical reactions and allowing greater efficiency. This was a quiet revolution of structure, an internal choreography that would allow future life to develop tissues, organs, and eventually consciousness itself. It was a step so small it could not be seen without a microscope, yet it was one of the most profound transitions in Earth's history. Complexity was no longer just a possibility, it had begun to take shape. Time in the oceans moved differently than we perceive it now. Millions of years passed like a single heartbeat, yet each moment left an indelible mark. Life adapted to temperature shifts, chemical fluxes, and the slow circulation of nutrients. Extinctions occurred silently, leaving gaps that allowed new forms to flourish. The oceans were both theater and teacher, demonstrating the resilience necessary for survival. Through persistence, variation, and countless cycles of growth and decay, life was refining its blueprint. The Earth was becoming a canvas upon which evolution would paint increasingly intricate patterns. The interplay between light, water, and chemistry also became more complex. Sunlight filtered through the oceans, reaching only certain depths, creating gradients of energy. Life responded to these gradients, exploiting niches and developing specialized adaptations. Some organisms floated near the surface, capturing light for photosynthesis. Others retreated into the darker depths, drawing energy from chemical reactions at hydrothermal vents. Each adaptation contributed to a balance, a rhythm that allowed diverse forms to coexist. Even in its invisibility, the ocean's ecosystems were beginning to resemble the intricate web that would later characterize all of life. Over time, the oxygen produced by cyanobacteria began to leak into the atmosphere, changing the nature of Earth's skies. The air, once dominated by inert gases, slowly became capable of supporting more energetic chemical reactions. The stage was being set for the emergence of multicellular life, for the migration of organisms into new environments, and eventually for life to claim the land itself. What had begun as invisible chemistry within the ocean now had the power to alter the entire biosphere. Life was no longer a passive passenger on the planet. It had become an architect, reshaping the world in ways that would ripple across eons. There is a profound humility in considering this slow transformation. Life's power did not emerge in sudden spectacle or dramatic events. It emerged quietly, persistently, often unnoticed by anyone, even by itself. The oceans, for all their turbulence, were nurturing a patient creativity, a meticulous crafting of conditions necessary for complexity. The story of these early ecosystems is not one of triumph or failure. It is a testament to the endurance of subtle processes, to the invisible forces that gradually shape existence. In the quiet of the ocean, life learned to persist, to adapt, and to transform the world. Even today, the legacy of these ancient oceans can be felt. The oxygen we breathe, the complexity of multicellular life, the very stability of Earth's ecosystems, all are echoes of the patient work performed in silence billions of years ago. The oceans themselves, vast and deep, remain reservoirs of memory, preserving chemical rhythms and biological strategies that first appeared in the dim and churning waters of the Precambrian. By observing them, we glimpse the hidden patience of creation, the slow unfolding of life from simplicity to extraordinary intricacy. The oceans, then, were not merely habitats, they were the first storytellers of the Earth. Every current, every chemical reaction, every light gradient carried a narrative of endurance, adaptation, and possibility. In their silence, they instructed life in the rhythms of survival, cooperation, and transformation. They taught that existence is not a single event but a continuum of experiments, each small, fragile, and imperceptible, yet together capable of shaping the fate of a planet. In the patient murmur of the oceans, life learned the art of becoming, and the Earth began to hum with the promise of all that was yet to come. As life in the oceans grew more complex, a quiet tension began to build, an invisible pressure that would shape the course of evolution for billions of years. For eons, single-celled organisms had dominated, drifting through the water, splitting, absorbing, and quietly transforming the chemistry of the seas. But slowly, tiny aggregations began to emerge. Cells that had once lived independently started to adhere to one another, forming primitive colonies. They were still simple, still invisible to any observer, but they carried the first whispers of a radical possibility: cooperation. In this subtle innovation, life was learning that existence could be more than survival. It could be collective, relational, and enduring. These early colonies were not conscious in any sense we understand. They did not communicate in language, they did not plan, they did not strategize. Yet through adhesion and cooperation, they created a foundation for complexity. Compartments formed, specializations emerged, and cells began to depend on one another for survival. The ocean, which had once been a place of solitary chemical experiments, was now becoming a theater for interaction. Life was beginning to learn the rhythms of interdependence, the subtle dance of mutual existence that would eventually allow for the emergence of multicellular organisms, and far beyond, intelligence. Time in this period was measured not in days or years, but in the slow pulse of geological change. Ocean currents shifted, temperatures rose and fell, nutrients fluctuated, and environmental pressures sculpted life invisibly. Each perturbation, each chemical gradient, each minor catastrophe became a lesson. Organisms that could adapt survived, while those that could not vanished silently. Extinctions, though unnoticed, were as formative as survival, pruning the tree of life in ways that allowed complexity to flourish. In these deep waters, evolution was a patient tutor, guiding the earliest communities toward resilience, specialization, and innovation. The rise of multicellularity was a quiet revolution. No explosion of life marked its arrival. There were no witnesses, no fanfare. But it was a profound step. Cells became interdependent, distributing labor and energy. Some focused on gathering nutrients, others on defense or reproduction. Specialization allowed efficiency, efficiency allowed growth, and growth eventually allowed the emergence of forms that could manipulate their environment in ways unimaginable for solitary cells. In the simplest terms, life learned to divide and conquer, not through violence, but through harmony, subtly laying the foundation for everything from coral reefs to forests, from fish to humans. This new phase also brought new vulnerabilities. Groups of cells could fail as easily as they could succeed. The ocean was a crucible, teaching that collaboration required balance. Cells had to coordinate, regulate, and communicate in microscopic ways. Failure meant dissolution, oblivion, erasure from the tiny yet infinite ledger of life. And yet, through repeated cycles of trial and endurance, multicellular life stabilized. It had learned one of the most profound lessons in the history of the Earth. Survival is rarely about isolation, and evolution is rarely about strength. It is about connection, timing, and subtle cooperation across scales invisible to the eye. Meanwhile, the atmosphere continued its slow transformation. Oxygen released into the seas by photosynthetic organisms gradually escaped into the air, thickening and stabilizing it. The sky, once heavy with inert gases, now began to support chemical reactions that would enable new metabolic pathways. The oceans and the atmosphere were no longer separate. They were a continuous system, each influencing the other, each shaped by the patient work of countless microscopic pioneers. Life, still confined to water, was quietly remaking the planet to suit its own expansion. In this way, existence became both agent and architect, shaping the conditions of its own survival. The emergence of multicellularity also introduced spatial dynamics. Life was no longer confined to diffusion or random drift. Tissues, colonies, and eventually organisms could influence their immediate environments, create gradients, and alter local chemistry. Shallow pools and oceanic shelves became laboratories for experimentation. Currents that once simply carried nutrients now interacted with these organisms, distributing offspring, influencing chemical patterns, and amplifying evolutionary pressures. Life had begun to engage with its environment intentionally, in the only way it could at the time, through presence, influence, and persistence. Perhaps the most poetic aspect of this stage is its invisibility. These critical transformations occurred on scales far too small for human perception, yet they determined the trajectory of life for billions of years. Every modern organism, from the smallest bacterium to the largest mammal, carries the legacy of this quiet revolution. Multicellularity is not merely a biological fact. It is a testament to the patient, invisible work of life learning to endure, adapt, and collaborate. The oceans, in their silent rhythms, nurtured these lessons. Currents, tides, and chemical gradients became the instructors of evolution, teaching cells how to exist not alone, but together, shaping complexity from simplicity, order from chaos. In contemplating this age, one recognizes the profound subtlety of Earth's storytelling. It is not always in explosions, eruptions, or disasters that the planet crafts life. It is in patient accumulation, in invisible networks, in the quiet persistence of countless tiny interactions. The rise of multicellularity marks a threshold, the moment when life began to dream bigger, to experiment with coordination, and to explore the potential of scale. It is a lesson in patience, resilience, and subtle creativity, a reminder that even the smallest entities, acting together over immense spans of time, can reshape the world itself. The quiet revolution of multicellularity set the stage for another profound transformation, the emergence of movement. For billions of years, life had been bound to the currents, drifting where the oceans carried it, shaped by tides, waves, and chemical gradients. Survival had been largely a matter of persistence, adaptation, and subtle chemical negotiation. But at some point, life began to experiment with motion of its own making. Cells developed the ability to change position, to extend, contract, and propel themselves. What was once entirely at the mercy of external forces was now able, in the smallest increments, to exert agency over its own existence. Movement, at first, was simple and almost imperceptible. Tiny cilia and flagella allowed cells to glide or spin through water, to follow nutrient gradients or escape localized danger. It was not conscious in any way we would recognize, yet it was a profound innovation. For the first time, life was no longer entirely reactive. It was proactive, shaping its immediate environment and exploring new niches. This capacity for motion transformed ecological dynamics. The ocean, once a medium through which life drifted passively, became a landscape to navigate, an arena for interaction and adaptation. As multicellular organisms appeared, movement became more sophisticated. Cells could coordinate, creating contractile tissues that allowed entire colonies or primitive animals to change shape, bend, and crawl. Some organisms developed primitive appendages, while others learned to flex their bodies rhythmically to move efficiently. These early innovations in locomotion were slow, small, and fragile, yet they set in motion an evolutionary cascade. Life was learning that space could be navigated, that distance could be conquered, and that the environment was not a passive backdrop but an interactive canvas upon which survival and exploration could occur. This new mobility also brought new challenges. Moving organisms faced predation, competition, and the energetic costs of motion. Life now needed strategies to conserve energy, to evade threats, and to exploit opportunities. Early sensory mechanisms emerged, rudimentary light detection, chemical sensing, and mechanical responsiveness, to guide movement. In these small steps, life was beginning to gather information from the world, learning to perceive, respond, and adapt with increasing subtlety. The first forms of behavior, simple though they were, had appeared. Life was no longer merely existing, but interacting with its environment in ways that would eventually become strategy, intelligence, and choice. The oceans themselves became more dynamic theaters. Currents, once neutral carriers of life, now influenced and were influenced by moving organisms. Food sources could be tracked, territories could be claimed, and symbiotic relationships could develop in new ways. Movement allowed organisms to escape the limitations of their initial chemical niches and explore gradients of temperature, salinity, and nutrient availability. Each new mobility adaptation opened doors for further experimentation and complexity, establishing patterns that would underpin ecosystems for eons to come. Even the smallest motions had profound consequences over geological time. Moving organisms disrupted sediment, altering habitats and shaping microenvironments. They carried chemical compounds across distances, facilitating interactions that were previously impossible. Movement accelerated evolution. Organisms encountering new environments adapted in response, triggering cascading changes that would ultimately support the rise of predation, competition, and more complex ecosystems. What began as tiny cilia or flexible membranes became the first instruments of exploration, experimentation, and evolutionary opportunity. There is poetry in this subtle emergence of agency. For eons, life had existed quietly, drifting and persisting, passive yet resilient. And then, almost imperceptibly, life learned to move. This small capability, motion without intention, agency without awareness, altered the trajectory of existence. It created the possibility for interaction, for challenge, for creativity. It allowed life to test boundaries, to probe limits, to leave the safety of stagnation in favor of exploration. In this sense, movement is not merely physical, it is existential, a declaration that life seeks to participate actively in the world, to influence the environment, and to expand the horizon of possibility. The first movements also set the stage for predation, which would transform life even more profoundly. Once organisms could seek food rather than wait for it to arrive, a new kind of ecological pressure emerged. Survival became more dynamic, competition more immediate, and the arms race of evolution began in earnest. Movement, in its quiet emergence, reshaped the ocean's dynamics and initiated a cascade of selective pressures that would guide the development of complex sensory systems, nervous tissues, and eventually intelligence. The ocean was no longer only a medium of chemistry, it was now a theater of interaction, choice, and emergent strategy. Even now, as we watch the motions of life across Earth, we trace them back to these first experiments in locomotion. Every fish that swims, every bird that flutters, every mammal that walks or runs carries the legacy of that subtle, invisible revolution. Movement is the heartbeat of interaction, the pulse of engagement with the world. It transformed passive survival into active exploration and paved the way for ecosystems that could innovate, adapt, and remember. In the patient, quiet oceans of the Precambrian, life first learned to move, and in doing so, began the long journey toward agency, awareness, and ultimately, consciousness. As movement became a defining feature of life, the oceans began to hum with invisible competition and cooperation. For billions of years, organisms had existed largely in isolation, drifting passively, confined by the limitations of diffusion and chemical gradients. But with the capacity to move, new dynamics emerged. Some organisms became hunters, seeking food actively rather than waiting for it to arrive. Others became grazers, scavengers, or filter feeders, exploiting niches that had previously been inaccessible. Predation, slow, small, almost imperceptible at first, transformed the oceanic world. Life was no longer simply about survival, it was about strategy, timing, and adaptation, introducing a subtle yet profound layer of complexity. Predation reshaped evolution in ways previously unimaginable. Simple strategies, speed, stealth, or the ability to cling to surfaces became matters of life and death. Organisms that could sense their environment more accurately or react faster had advantages that multiplied over generations. This invisible pressure created a feedback loop. Adaptations led to counter-adaptations, which led to further refinements, producing an ever-increasing diversity of forms. In the dark, churning oceans, a silent arms race began, invisible to any observer but written into the DNA of countless organisms. The dance of predator and prey, though subtle at first, would become the engine of complexity. At the same time, cooperation flourished alongside competition. Some multicellular organisms developed specialized cells that worked together to gather nutrients or defend against threats. Symbiosis became increasingly common. Organisms paired or grouped to mutual benefit, sharing resources, shelter, or chemical processes. In this subtle interplay, life was learning one of the most enduring lessons of existence. Survival is rarely solitary. Even in its earliest forms, life depended on networks, interactions, and relationships that extended beyond individual organisms. This was a lesson that would resonate through billions of years of evolution. Environmental pressures also intensified as life became more active. Oxygen levels were rising, changing the chemistry of the oceans and creating new opportunities and new challenges. Shallow waters, previously inhospitable, became viable habitats for those capable of movement. Tidal pools, reefs, and continental shelves emerged as complex landscapes of opportunity and risk. Life began to explore vertical space as well as horizontal, inhabiting layers of water previously unoccupied. This exploration expanded the potential for ecological diversity, allowing specialized adaptations to flourish. Life was learning not only to move, but to occupy and shape space. The interplay of predation, cooperation, and environmental change accelerated evolution in profound ways. Organisms experimented with new forms of sensory perception, rudimentary eyes, chemical sensors, mechanoreceptors, capable of guiding movement and behavior. Nervous systems, in their earliest incarnations, began to coordinate activity within organisms, allowing for more sophisticated responses to stimuli. The ocean became a stage for the emergence of sensation, response, and interaction, a quiet prelude to the development of intelligence. Life was not conscious, yet it was learning patterns that would eventually underpin awareness and decision-making. This era also introduced subtle shifts in energy use. Active movement required energy in ways that passive drifting never had. Organisms evolved metabolic efficiency, storing and distributing energy to support sustained activity. Muscles and contractile tissues became increasingly specialized, allowing for more precise movement. Life was experimenting with energy allocation, balance, and efficiency, lessons that would prove essential for future complexity. Even in its smallest forms, the principles of trade-offs, investment, and optimization were being explored within the hidden depths of the Precambrian seas. The rise of predation and movement also created new selective pressures on reproduction. Organisms that could move were capable of spreading offspring over greater distances, avoiding localized extinction events. Fertilization strategies adapted to mobility, and early forms of sexual reproduction may have emerged as a response to these dynamic environments. Life was no longer static, it was dynamic, experimental, and responsive, exploring possibilities that would shape the trajectory of evolution for billions of years. Every ripple of motion, every encounter between predator and prey, every subtle adaptation, carried echoes into the future. In contemplating this stage of life, one is struck by the interplay of violence and creativity. Predation, often perceived as destructive, was in fact a driver of innovation, shaping form, function, and strategy. Cooperation, appearing alongside it, allowed resilience and exploration. The ocean, once a passive medium, became an interactive landscape of challenges and possibilities. Life was learning, slowly and invisibly, the lessons of balance, adaptation, and interaction, lessons that would eventually culminate in the astonishing complexity of animals, plants, and ecosystems. The quiet ocean of this time was alive with invisible drama. Though unseen and unnoticed, the struggle and cooperation between organisms laid the foundations for every ecosystem that would follow. Life, once passive, had become active. Once solitary, it had become relational. Once chemically reactive, it had become strategic. These early experiments in predation, cooperation, and mobility were not just biological, they were philosophical. They demonstrated that survival is relational, that adaptation requires engagement, and that complexity arises not in isolation, but in the interactions, challenges, and alliances that life creates with itself and with the world around it. Even today, in the patterns of modern ecosystems, we see the echoes of this age. Predator and prey, cooperation and competition, mobility and strategy, all trace back to these earliest innovations in the hidden depths of the Precambrian seas. The invisible dance of life in that era was the beginning of narrative, of history, of interaction. It was the moment when life began to write its own story, quietly, patiently, without fanfare, yet with consequences that would reverberate across billions of years. The oceans had become a teacher, a stage, and a laboratory, shaping the principles of life that endure to this day. With the foundations of movement, cooperation, and predation established, life in the oceans began to explore new frontiers of complexity. For billions of years, Organisms had existed largely within invisible chemical and mechanical limits. Yet now, through adaptation and interaction, they began to construct forms capable of structural innovation. Bodies became more organized, with specialized tissues and primitive organs. Circulatory channels emerged to distribute nutrients efficiently. Protective layers and skeletal elements appeared, providing resilience against predation and environmental stress. Life was beginning to experiment with architecture, crafting its own vessels of survival, each one a subtle masterpiece of evolutionary design. The oceans themselves became increasingly dynamic landscapes, filled with niches that demanded ingenuity. Shallow reefs, tidal zones, and continental shelves offered opportunities for both shelter and exploration. Organisms colonized vertical spaces as well as horizontal, inhabiting the water column in ways that were previously impossible. Each adaptation, whether a spiny exoskeleton, a flexible fin, or a sensory appendage, was a response to environmental complexity. Life was no longer passive. It was shaping its world even as it responded to it. The interplay of organism and environment became a feedback loop, each influencing the other in subtle yet profound ways. Reproduction, too, became more elaborate, responding to new ecological pressures. Mobile organisms could disperse offspring across greater distances, reducing the risk of localized extinction. Early sexual reproduction may have emerged as a response to environmental variability, introducing genetic diversity and increasing adaptability. Life was learning to hedge its bets, experimenting with strategies that ensured persistence across time and space. The ocean, once a medium of chance encounters, had become a landscape of opportunity and challenge, a stage for both innovation and risk. Predation and competition continued to refine form and function. The arms race between hunters and prey drove the evolution of speed, agility, camouflage, and defense. Sensory systems became increasingly sophisticated, allowing organisms to detect chemical, visual, and mechanical cues with precision. Nervous systems evolved in complexity, coordinating movement and response in ways that enabled increasingly intricate behaviors. Life was not yet conscious, yet it was learning the principles of interaction, strategy, and environmental awareness. These lessons, written into the bodies and behaviors of organisms, would echo through countless generations. Energy management became a central theme of survival. Motion, defense, reproduction, and sensory activity all required efficient use of energy. Organisms evolved metabolic strategies to allocate resources optimally, balancing activity with conservation. Muscles, contractile tissues, and storage organs developed in response to these pressures. Life was experimenting with the principles of energy economy long before humans ever understood them, crafting solutions that would enable complex ecosystems to flourish. Even at microscopic scales, the management of energy became a narrative of survival and innovation. The emergence of structural complexity also facilitated new interactions within ecosystems. Organisms began to modify their environments, creating microhabitats and influencing nutrient flow. Coral-like formations, microbial mats, and sediment stabilization by early organisms provided niches for others. Life became both actor and architect, shaping the world while responding to it. The oceans were no longer mere containers for chemical reactions. They had become collaborative spaces where life and environment were inseparable, a continuous dance of adaptation and influence. The subtle interplay of biology and environment during this era set the stage for further evolutionary milestones. Sensory and nervous systems prepared the way for coordinated movement, behavioral responses, and eventually predatory sophistication. Structural innovations enabled larger bodies, specialized organs, and more elaborate ecological roles. Each small advancement amplified possibilities, opening doors for entirely new forms of life to emerge. Life was learning to anticipate, to respond, and to influence, taking increasingly active roles in shaping its own trajectory. Perhaps most profound was the emergence of diversity itself. Previously, life had been constrained by simplicity and the limits of chemical and environmental factors. Now, through structural innovation, energy management, and environmental interaction, ecosystems began to flourish with unprecedented variety. Multiple strategies coexisted, competing and cooperating in delicate balances that produced resilience. The oceans had become a rich tapestry of life, each thread woven through billions of years of patient experimentation. Complexity was no longer the exception, it was the inevitable consequence of persistence, adaptation, and interaction. In contemplating this stage, one sees the quiet genius of the oceanic world. Life's innovations were incremental, almost imperceptible, yet cumulatively transformative. Each new tissue, each new structure, each new behavior was a rehearsal for the ecosystems and creatures that would follow. The ocean had taught life the principles of design, energy, interaction, and persistence. It had prepared life not just to exist, but to thrive in intricate, interdependent communities. These early lessons in complexity laid the groundwork for every multicellular organism that would follow, from the simplest filter feeder to the most elaborate predator, and eventually, to beings capable of reflection, imagination, and understanding. Even today, the echoes of this era resonate in the structure of life around us. The architectural innovations, energy strategies, and ecological interactions of early oceanic life underpin the principles of modern biology. Each organism, each ecosystem, carries within it the accumulated wisdom of billions of years of experimentation. Life, through patience and subtlety, had learned not only to survive but to invent, to modify, and to orchestrate complexity from simplicity. The oceans, in their silent, invisible work, had nurtured a world capable of endless possibility, a world that would one day extend its reach beyond water to the skies, the land, and consciousness itself. As structural complexity and interaction flourished in the oceans, life began to reach a subtle but profound threshold, the ability to sense and respond to the world in increasingly sophisticated ways. Early sensory mechanisms, once rudimentary, evolved to detect gradients of light, chemicals, and motion with remarkable precision. Some organisms developed simple photoreceptors, allowing them to orient toward or away from sunlight. Others responded to vibrations, sensing the presence of nearby predators or prey. Even without consciousness, these capabilities introduced the first forms of perception, enabling life to act in ways that were anticipatory rather than purely reactive. In this quiet revolution, life was beginning to perceive itself as part of a larger environment. The evolution of sensory systems also transformed behavior. Movement was no longer random or purely driven by chemical gradients. It became directed, purposeful in its own way. Organisms could now seek nutrients, avoid threats, and explore niches more efficiently. Simple circuits within primitive nervous systems coordinated these responses, linking sensation to action in subtle feedback loops. Life had begun to learn about its own capacities and the structure of its environment. This early perception was a rehearsal for awareness, a faint echo of the conscious engagement that would appear much later, yet it marked a turning point. Life was beginning to interact with the world as a participant rather than a passive occupant. Predation, too, was refined by sensory evolution. Hunters became more adept, able to detect subtle chemical trails or the faintest vibrations in the water. Prey developed defensive strategies, including rapid escape responses, camouflage, and protective structures. The ocean became a theater of invisible tension, where evolutionary pressures acted not just on structure and energy, but on perception and behavior. Life was learning that success required not only strength and mobility but attentiveness and responsiveness. Every ripple of water, every shift in light, every chemical signal became a source of information to guide survival and interaction. The increasing complexity of sensory and nervous systems also set the stage for the first coordinated behaviors among multicellular organisms. Groups could move together, respond to environmental cues collectively, and even perform rudimentary forms of communication. Swarming, schooling, and colony coordination became possible, multiplying the potential for survival and ecological influence. Life was learning the dynamics of interaction, cooperation, and coordination on both micro and macro scales. The ocean, once merely a medium of chemistry and motion, had become a classroom in perception and strategy, where lessons in awareness and responsiveness were quietly recorded in DNA. Energy allocation remained central to this stage. Sensing the environment, moving purposefully, and responding to stimuli all required careful management of resources. Organisms that optimized energy use survived and reproduced more effectively, reinforcing adaptations that enhanced sensory acuity, mobility, and coordination. Life was learning not just to exist, but to economize, to invest in the faculties that increased survival probability. These early lessons in balance, efficiency, and strategic allocation of effort are echoed in the behavior of complex organisms today, from the foraging patterns of fish to the hunting strategies of predators. The subtle emergence of perception also amplified evolutionary innovation. Organisms capable of sensing their environment could exploit previously inaccessible niches, avoid hazards, and find partners or resources with greater precision. Sensory acuity enabled specialization, which in turn supported ecological diversification. Reefs, shelves, and deep-sea vents became arenas of complex interaction, where life was no longer passively shaped by its environment but actively responding to and reshaping it. Perception became both tool and medium, a way to understand the world and a way to participate in its ongoing creation. There is a poetic dimension to this stage of life. For eons, organisms had drifted and persisted, simple and blind to the wider patterns of their existence. And then, almost imperceptibly, the world began to make sense to them. They detected light, chemicals, and motion. They sensed proximity, danger, and opportunity. Life was learning to read its environment, a form of cognition that preceded thought and consciousness. In these first forms of perception, we glimpse the embryonic principles of awareness, attention, response, and adaptation, qualities that would echo through evolution into intelligence, curiosity, and reflection. Even today, the principles established in this era resonate in every nervous system, every sensory organ, and every coordinated behavior. The ocean's first experiments with perception laid the groundwork for sight, hearing, taste, touch, and smell. They taught life to anticipate, respond, and engage. They initiated the slow, patient journey from blind reaction to intentional action, from passive existence to interactive complexity. In the depths of ancient seas, life began to learn the fundamental lesson that would define its future. To survive and thrive, one must not only move and endure but also perceive, understand, and respond to the subtle currents of the world around it. By the end of this stage, the ocean was no longer merely a home for life. It was a teacher. It had instructed life in structure, energy, cooperation, movement, and perception. Each organism carried within it the lessons of these billion-year experiments, the invisible imprint of evolutionary trial and error. The ocean had guided life from chemical reaction to agency, from passive drift to interactive engagement. In the silent currents of these ancient seas, life had learned to sense, to respond, and to prepare for the extraordinary leaps that awaited it in the next stages of evolution. As sensory systems and movement became increasingly refined, life in the oceans began to explore dimensions of existence previously inaccessible. No longer merely drifting or reacting to chemical cues, organisms could navigate their environments with purpose, detect subtle patterns, and interact with one another in increasingly complex ways. Simple neural networks allowed the coordination of multiple functions simultaneously: movement, feeding, defense, and response to stimuli. Life was learning not just to exist, but to negotiate its place in a world full of opportunity, risk, and intricate interdependencies. In this way, the oceans became a stage where strategy, perception, and interaction unfolded, silently shaping the path of evolution. The refinement of locomotion and sensory perception introduced new forms of ecological complexity. Organisms began to occupy specific niches with increasing specialization, developing strategies that allowed coexistence and resource partitioning. Some organisms adapted to the darkest depths, harnessing chemical energy from hydrothermal vents. Others exploited the sunlit surfaces, capturing energy through photosynthesis or ambushing prey. Each adaptation created ripple effects, influencing the distribution, abundance, and behavior of other organisms. The ocean transformed into a dynamic web of interdependence, a subtle choreography of energy, matter, and response. Predation reached new heights of sophistication during this period. Hunters developed sensory acuity and motor coordination that allowed them to detect and capture prey with increasing efficiency. Prey species responded with countermeasures, camouflage, defensive structures, rapid escape responses. This invisible arms race accelerated evolutionary innovation, shaping body plans, behaviors, and survival strategies. The interaction between predator and prey became a central driver of complexity, teaching life the delicate balance between risk and opportunity, attack and defense, initiative and caution. Even without consciousness, life was engaged in a form of strategic interaction that would echo across eons. The emergence of larger, more complex body plans brought further evolutionary possibilities. Multicellular organisms began to develop distinct tissues and organ systems, each specialized for particular functions. Digestive structures, contractile tissues, sensory organs, and protective layers allowed life to exploit its environment more effectively. The diversification of form and function enabled exploration of new ecological niches and behaviors. Life was now capable of inhabiting vertical space, extending its influence into the water column in ways that single-celled or simple multicellular organisms could not. The ocean became both laboratory and canvas, a place where experimentation and adaptation intertwined seamlessly. Coordination within and between organisms also became more sophisticated. Colonial and social behaviors emerged in simple forms, including collective movement, group defense, and cooperative feeding strategies. Communication, though primitive, allowed organisms to share information indirectly through chemical signals or movement patterns. These behaviors laid the groundwork for the social dynamics that would eventually characterize many animal lineages. Life was learning that survival and success could be enhanced not just by individual adaptation but by interaction and cooperation, establishing principles that would echo in the evolution of intelligence and sociality. Energy allocation and metabolic innovation remained central to survival. The demands of coordinated movement, sensory processing, reproduction, and defense required efficient distribution and utilization of resources. Organisms that optimized energy flow were more resilient and adaptable. Muscular and contractile systems, sensory organs, and internal transport mechanisms evolved in concert, creating bodies capable of sustained activity and sophisticated environmental engagement. Life was experimenting with internal efficiency, establishing patterns that would allow increasingly complex behaviors, ecological interactions, and evolutionary diversification. This stage also saw the early emergence of rhythm and cyclicity in life processes. Tidal cycles, day-night patterns, and seasonal variations influenced movement, feeding, and reproduction. Organisms developed timing mechanisms that allowed them to anticipate environmental changes, aligning activity with optimal conditions. These rhythms introduced an element of temporal awareness, an early form of adaptation to predictable patterns that would eventually influence behavior, reproduction, and survival strategies. Life was learning to exist not only in space but in time, integrating external cycles into internal processes. The cumulative result of these innovations was a remarkable increase in diversity and resilience. Ecosystems became complex, interconnected networks, where the fate of one species influenced many others. The oceans, once a medium of passive chemistry and simple motion, had become a dynamic, interactive environment shaped by the collective activity of countless organisms. Life was no longer merely responding to the environment. It was participating in its shaping, creating feedback loops that would guide evolutionary trajectories for billions of years. In contemplating this age, one is struck by the subtle genius of evolution. Complexity did not emerge suddenly, it arose gradually, through incremental innovations in perception, movement, coordination, and energy management. Life learned patience, persistence, and interaction, developing strategies that would support increasingly elaborate forms and behaviors. The oceans taught the lessons of engagement, adaptation, and interdependence, providing both opportunity and constraint, nurturing innovation while imposing limits. Every ripple of water, every current, every chemical gradient became a tutor, guiding life toward sophistication. Even today, the principles established during this stage resonate across all forms of life. Nervous systems, sensory organs, coordinated behaviors, and ecological interactions all trace their roots to this era of quiet experimentation. The oceans shaped life not only as a habitat but as a teacher, fostering patterns of perception, movement, and interaction that would define the evolutionary potential of the planet. In the patient, invisible dynamics of these ancient seas, life learned to navigate space and time, to sense and respond, to coordinate and cooperate, a foundation upon which all subsequent complexity, intelligence, and consciousness would be built. As the oceans matured into vast arenas of life and complexity, the stage was set for the most profound and transformative events yet to come. For billions of years, life had existed in hidden, patient forms, drifting, sensing, moving, cooperating, and subtly shaping its environment. Now, the cumulative effects of structural innovation, sensory perception, mobility, and interaction began to reach a tipping point. The ocean itself, shaped and guided by the organisms within it, had become a dynamic, responsive system capable of supporting life on scales and in ways previously unimaginable. This era was the quiet prelude to emergence, a moment of preparation before the next grand chapter in Earth's story unfolded. The innovations of multicellularity, movement, predation, and sensory perception had created a foundation for diversification on a scale the planet had never known. Organisms now existed in an intricate network of interactions, each influencing countless others in subtle ways. Food chains and ecological webs were forming, with relationships of dependence, competition, and cooperation defining the distribution of life. Evolution, previously a slow accumulation of simple adaptations, now operated within a context of escalating complexity. Every change had cascading effects, and every interaction carried the seeds of future innovation. Life was poised on the brink of explosion, not sudden, dramatic, or obvious, but inevitable in its consequence. This threshold also marked the rise of specialization on an unprecedented level. Organisms developed discrete functions, tissues, and behaviors finely tuned to environmental conditions. Some became filter feeders, others active hunters. Some specialized in photosynthesis, others in predation. Sensory systems became increasingly refined, allowing organisms to detect and respond to subtle cues in their surroundings. Movement became coordinated and precise, guided by both environmental stimuli and internal organization. Life was learning not only to survive but to optimize, to inhabit niches with increasing sophistication, and to navigate a complex, changing world with remarkable efficacy. The interactions between organisms intensified in both subtle and dramatic ways. Predation, now guided by sensory perception and coordinated motion, created selective pressures that drove rapid adaptation. Cooperative behaviors and symbioses multiplied, creating networks of interdependence that amplified survival opportunities. Energy flow, previously a matter of simple chemical acquisition, became a complex web of metabolic strategies, distribution, and optimization. Organisms were no longer merely responding to their environment. They were shaping it, influencing nutrient cycles, habitats, and even chemical gradients in ways that would ripple across ecosystems for millions of years. Temporal awareness also became more pronounced. Life began to anticipate environmental cycles with increasing precision, responding to tides, day-night rhythms, and seasonal fluctuations. Reproductive cycles, feeding patterns, and migratory behaviors were synchronized with these external rhythms, enhancing survival and efficiency. The ocean, once a neutral medium, became a temporal and spatial classroom in which life learned to coordinate activity across both dimensions. Adaptation was no longer reactive alone, it was anticipatory, integrating the principles of rhythm, timing, and expectation into the strategies of survival. The stage was also set for ecological experimentation on a planetary scale. Shallow seas, reef structures, and continental shelves became arenas for innovation. Organisms modified their surroundings, stabilizing sediments, constructing structures, and altering chemical conditions. Life became both actor and architect, demonstrating that persistence and interaction could shape the very fabric of the world. This coevolution of environment and organism amplified complexity, preparing the oceans for the emergence of entirely new forms, behaviors, and strategies that would dominate the Earth in the ages to come. Even in this final stage, the lessons of patient, incremental innovation are clear. Evolution did not rush, and complexity did not arrive fully formed. Life learned to endure, to move, to sense, to cooperate, and to anticipate. Every small adjustment, every subtle adaptation, every interaction, whether predator-prey, symbiotic, or competitive, contributed to a narrative of resilience and innovation. The oceans, in their silent, persistent rhythms, had become both cradle and teacher, nurturing principles that would guide life long after these first chapters of visible complexity had passed. This moment, when life was poised on the edge of extraordinary diversification, reflects the profound patience of evolution. Billions of years of quiet experimentation, imperceptible to any observer, had created the conditions necessary for the rapid emergence of ecological complexity that would define the Phanerozoic era. It was a reminder that the most profound transformations often arise not through sudden leaps but through cumulative persistence, patient adaptation, and countless small, invisible experiments carried out over unimaginable spans of time. As we reflect on this age, we see the foundations of all that followed: the intricate web of life, the principles of adaptation and cooperation, the emergence of sensory perception, mobility, and strategic behavior. The oceans had nurtured the first lessons in resilience, interaction, and subtle power. They had prepared life for the eventual conquest of land, the rise of forests, and the evolution of consciousness itself. This was the age that ended before it began, a quiet prelude, almost invisible, yet containing within it the blueprint for every living story that would follow. The patient, hidden work of billions of years had crafted a world ready for explosion, for innovation, and for the extraordinary diversity that would one day teem across the Earth.